Hey guys, today we were talking about finding and graphing inverse functions. So the main thing is that we're going to find the inverse and then we're going to put it on the graph using our parent table and our chart. So remember, to find an inverse function, what we need to do is we need to switch my x and y, and that's kind of the big thing here. So what we're going to do first is we are going to start here with our equation given, and it's log base 2 of x plus 3. And the first thing we're going to do is switch x and y. So I'm going to switch, this f of x is going to become an x, and this this x in here is going to become a y. So we'll have y plus 3 on the inside. Then we're going to solve for my new y. Now before we do that, I want you to notice what my new equation is going to be. Since we started off with a log base 2, we're going to finish with a exponential of 2. And since I started with a plus 3 on the inside, we're going to finish with a minus 3 on the outside. And then we're going to take a moment to graph that. So let's go ahead. To get rid of this log base 2, we are going to go the base of 2 to the power of x equals y plus 3. So it's going to be 2 to the power of x equals y plus 3. Then, to get that y by itself, all I got to do is minus 3 to both sides, and we get y equals 2 to the x minus 3. And notice that there's a space here to write out our new equation here. So it's going to be 2 to the x minus 3. And that's what my inverse function is going to be. Now, it's wanting us to graph our inverse function, not the function that we started with. It's wanting to graph our inverse. So we're going to take this inverse, and we're going to be putting it on this graph over here. Okay? Now, the main thing to be able to graph these is we need to be able to find my asymptote. Okay? So if you can find your asymptote and your x and y intercept, you can graph anything. Now, I want to remind you that a exponential function has a horizontal asymptote. So this one here is going to have a horizontal asymptote. A horizontal asymptote. And I'm going to give you a little way to remember what a horizontal, which one's horizontal, which one is vertical. So, if you ever see an exponential equation, an exponential equation has a horizontal asymptote. And think about that E, just kind of shooting off and creating that horizontal asymptote. All right? Now, a logarithm equation, think about that L, how it's straight up and down. That L on my logarithm is straight up and down, and that creates a vertical asymptote. So if it's a logarithm, we have a vertical asymptote. If we have an exponential, we have a horizontal asymptote. Okay? All right, so a horizontal asymptote also corresponds with my k value. So my horizontal asymptote is going to have the y equals whatever my k value is. So we're going to go y equals negative 3. And we can go ahead and put that on my graph over here. I can put a point, we can put a horizontal asymptote at y equals negative 3. All right? All right, so now all I need to do is find some points. We can find a y-intercept, an x-intercept. We can use my parent table. We can find my points to graph it out here. Now I just want to remind you what our graphs look like. Remember that a logarithm graph, it shoots off to the right. It starts along its vertical asymptote and then it shoots off to the right. But a logarithmic graph, an exponential graph, it starts at its horizontal asymptote and then it shoots up. And so that's kind of the different look. This is an exponential, so it's going to do that. It's going to come along here along the horizontal asymptote and then it's going to shoot upwards. Okay? So let's go ahead, let's fill in our parent table. Our parent table for an exponential kind of looks like this. We go negative 1, 0, 1. On the left-hand side, and then we're going to have 1 over my base, 1, and then whatever my base is. And in this case, my base was 2, so we're going to have 1 over 2, or 0.5, and then 2. And then to get my x values, what we're going to do is we're going to go add it to whatever h is. Now I don't have an h in this equation, so it's just going to be just whatever x is. So we just repeat this, -1, 0, 1. And then my k's, for each one of my k, we add my, for my y's, we're going to add my k values. So we're going to go each y minus 3, because minus 3 is my k value. So I'm going to go 0.5 minus 3 is -2.5. 1 minus 3 is -2. And 2 minus 3 is -1. And so we can put these points on our graph over here. We're going to have a point at -1, -2.5, so right about there. 0, -2, so right about there. And 1, -1, so right about there. And our graph is going to hug this horizontal asymptote, and then it's going to start spiking up whenever we hit these 3 points. And so you can kind of see where our graph is at. All right? To find my y-intercept and my x-intercept, we're going to do something very similar. To find my y-intercept, we're going to plug in my 0 for my x, and to plug in my x-intercept, we're going to plug in 0 for y. Now, we already know what my y-intercept is. It's right here. It's when my x is 0, and my x is 0 when y is -2. So we're going to have a point at 0, -2. But what about my x-intercept? To find my x-intercept, we're going to have to plug in 0 for y, and that's going to take us a moment. So we're going to take this original equation, and we're going to plug in 0 for y. We're going to go 0 equals 2 to the x minus 3. And we're going to solve this guy. We're going to add 3 to both sides. That's going to give me 3 equals 2 to the x. Then I'm going to rewrite it as a logarithm. We're going to go log base 2 of 3 equals x. So log base 2 of 3 equals x. And then remember, we can just plug that into our calculator to find what that value is. So I'm going to go ahead, we're going to plug that into our calculator. I'm going to go log of 3 divided by log of 2. Remember, that's the change of base formula. So log of 3 divided by log of 2. Hit enter, and we're going to get 1.585. So we're going to have an x-intercept at 1.585, 0. All right, and now that I know where my graph goes, we know it looks like this. And we kind of match it up. We have our x-intercept at 1.585. Hey, that's pretty close. We have our y-intercept at 0, -2. My domain, think about it. Remember, your domain is your left to your right. It's everything to the left, everything to the right. In this graph, it's going to go forever to the left and forever to the right. It's going to go really fast up, but eventually it's going to get out to the right as well. So my domain is going to be all real numbers, -infinity to +infinity. My range is the one that I have to think about. But I want you to remember, your horizontal asymptote and your range are connected. My range is connected to my horizontal asymptote, and it's going to go above the asymptote. So my range is going to look like this. It's just going to be y is greater than my asymptote, which isn't 0. I don't know why I keep doing that. My range is going to be greater than -3. Okay, so my range is greater than -3. And we can also write that as -3 to infinity. All right, before we go too far, though, let me show you the easier way to do this. We have, what I really want you to focus on is 2 things. I want you to focus on being able to find your inverse and also how to be able to find the asymptote. Okay, if you can do those 2 things, you're good to go. So what we're going to do is and then to graph it, you can just plug it into your calculator. We can go y equals, and we can plug this guy into our calculator. We can go we can go 2 to the x minus 3. Y equals 2 to the power of x, click 1 over, minus 3. And then we can show it on our graph. Look at our graph. It goes along the horizontal asymptote, and then it spikes up. Okay? And so that horizontal asymptote's at -3, and we can see that. But we can also look at the table. We can go second table. Okay, try this again. Second table. There it goes. And so we can have one in our second table, and you can see the points, the same points that we just got. -1, -2.5, 0, -2, 1, -1, 2, 1, 3, 5. And so you can see how it's starting to spike up there. Okay? So that can be really helpful for us. All right, so use your calculator to your advantage. All right, now let's go the other direction. We started on this problem, we started with a logarithmic equation, and we found the inverse, which was an exponential. But now, let's start with an exponential and solve for its logarithmic inverse. Okay, so first step to solving for an inverse is switch x and y. So we're going to make this f of x, x, and we're going to make that x up there, y. So we'll have y plus 1 and then a plus 3 on the end. Whenever we get this to be its inverse, we're going to have everything opposite. So instead of having a base of 10, we're going to have log base 10. Instead of having a plus 1 on the inside, we're going to have minus 1 on the outside. Instead of having plus 3 on the outside, we're going to have minus 3 on the inside. Everything's going to be switched around. So let's go ahead and solve for that. So we can start off by moving things over to x, so I can minus 3 to both sides. That's going to give me x minus 3 equals 10 to the y plus 1. Then we're going to rewrite it as a logarithm. We're going to go log base 10 of x minus 3 equals y plus 1. So log base 10 of, and I don't have to write the base 10, right? We don't have to write that. So we're going to go log of x minus 3 equals y plus 1. And then we're just going to minus 1 to both sides. And you can see how we ended up with our minus 1 on the outside and then a minus 3 on the inside. Okay, and so that's our new equation that we're going to need to graph. So, new equation, we're going to have log of x minus 3 minus 1. Now, I want you to remember, a logarithm has a vertical asymptote. Okay, a logarithm has a vertical asymptote. Think about that straight up and down L. It creates that vertical asymptote. And our vertical asymptote is x equals whatever my h is. And so in this case, my h is, it looks like it's negative 3, but it's actually positive 3. So my x is going to be positive 3. And so we can actually draw that over here on my graph. I can have a vertical asymptote at x equals positive 3. So I know my graph is a logarithmic graph, and so it's going to hug this asymptote and it's going to jump out to the right. Okay? But we need to figure out where exactly it's going to make that turn. Where exactly is it going to jump out to the right? So we're going to use our parent table to figure that out. So your parent table for a logarithm looks like this. It's going to be 0, 1, and then whatever your base is. And in this case, my base is 10. And then we just have error, 0, and 1 here. Okay? And so we can manipulate these points. So think about, we're going to go x plus whatever h is. Well, h is 3, so we're going to go x plus 3 for each one of these. And then y minus whatever my, y plus whatever my k is. But my k is minus 1, so we're just going to go y minus 1. So we can manipulate our points here. We can have a point at 0 plus 3 is 3. 1 plus 3 is 4. 10 plus 3 is 13. Goodness. 10 plus 3, I don't know where I got that 4 from. I guess from our last one. All right, so 10 plus 3 is 13. Then, on the other side, an error minus 1 is still going to be an error. And that makes sense because that's where my asymptote is. Then 0 minus 1 is negative 1, and 1 minus 1 is 0. And we can put our points over on the graph here. We're going to have a point at 4, negative 1, and we're going to have a point at 13, 0. Now 13 is like all the way out here on the end. And so you can see how it's going to start here, and then it's going to jump out. So we're going to hug this asymptote, and we're going to hit this point, and then we're going to jump out to the right. All right. Now, I want you to look at this graph, and you should be able to tell that we're not going to have an x-intercept because it's to the right of the x-axis, and we can't cross over this asymptote. So we are not going to have a y-intercept. So we can't get to that y-axis, so we're going to have no y-intercept. And my x-intercept, it already tells me what my x-intercept is. We have this point at 13, comma, 0. And so my x-intercept's at 13, comma, 0. So there you go. Our last two little things, our domain and our range. My domain is only going to be greater than my asymptote, okay? So on a logarithmic, your vertical asymptote and your domain are connected. And so we're going to say it's greater than my asymptote there, so it's going to be greater than 3. So it's going to be 3 to infinity. And my range, it's going to be, it doesn't look like it looks like it stops right here, but it technically is going to keep going up for forever. So my range, my up and down, is going to be all real numbers, negative infinity to positive infinity. Okay? Remember, you can use your calculator to help you figure this out, to help you look at your graph, and to help you look at some points that you know are going to go on your graph. All right? Okay, so let's go ahead and turn the page. We're going to do our last one. Number 3 right here, find and graph the inverse f of x equals natural log of x minus 5. So we start off with the natural log. We're going to be writing the inverse for this. So we're going to replace that f of x with an x. We're going to go x equals the natural log of y minus 5. Find the inverse, we're going to have to rewrite this. To rewrite a natural log, we're going to have to use a base of e. So we're going to go e to the x equals y minus 5. So e to the x equals y minus 5. Then we can just add 5 to both sides. And we can have e to the x plus 5 equals y. Now, this should make sense to you. The opposite of a natural log is exponential base e. The opposite of minusing 5 on the inside is adding 5 on the outside. So everything's switched around. And so that's going to be my inverse. It's going to be e to the x plus 5, and that's it. Okay? All right, and so we're going to have a horizontal asymptote on this one. Okay? Remember, exponential, that e keeps going out, and we have that horizontal asymptote. And your horizontal asymptote is attached to your k value. So my horizontal asymptote is going to be at 5. So up here at 5, we're going to have a horizontal asymptote. And my graph is going to be above that horizontal asymptote because it's not negative. Let's find some parent points for this. So remember how it goes for an exponential. It goes like this. If you have -1, 0, 1, then we have 1 over my base, which is e. You could also use 0.37. And then we have a point at 1, and then we have whatever my base is, which is e, or 2.7. Okay? So then, what we can do is we can rearrange these. We can, my x's are not going to change at all because I don't have an h. So my x's are just going to be -1, 0, 1. And my y's, we're going to add my k. So for each one of these, we're going to go y plus 5. So I'm going to go 0.37 plus 5 is 5.37. 1 plus 5 is 6. 2.7 plus 5 is 7.7. And we can see these points on my graph. We're going to have a point at -1, up here to 5.37. So right about there. We're going to have a point at 0, 6. And a point at 1, 7.7, so right about there. Okay? And so now we can draw our graph on here. It's going to hug this asymptote, and it's going to spike up. And then we can see that I do not have an x-intercept because it's not going to cross that x-axis because it's above that horizontal asymptote up top. So my x-intercept is that there's going to be no x-intercept. And then my y-intercept is going to be right here at 0, 6. Okay, so there we go. All right, it all worked out. My domain is going to be all real numbers. It's going to go all the way to the left, all the way to the right, so all real numbers, negative infinity to positive infinity. And my range is just going to be greater than my horizontal asymptote. So it's going to be y is greater than 5 or 5 to infinity. Okay? So there we go. We did it. I want to show you real quick before we go what this would look like in your calculator. So if we were to pull up our calculator, we would go to y equals, and you can plug this in, and you can go y equals e to the x plus 5, and we could look at our graph. Notice how it's up here at a horizontal asymptote of 5, and then it just spikes up right there, okay? And then we could also look at our chart here, or our table, the second table, and we can find the points that we just did. -1, 5.36, 7, 0, 6, 1, and 7.7, okay? So that kind of helps us out there. All right. Thank you for paying attention today. Hope you have a great rest of your day. Thanks, guys.